Catalysts. Catalysts increase the rate of reaction, and the way they do it is they decrease the activation energy of the reaction. So let's look at the picture here, our energy curve. Here's the activation energy without the enzyme. The enzyme lowers that peak to down to there. Okay, so that's the key function of a catalyst. So the graph is showing the decomposition of glucose both with and without a catalyst. Notice the energies of the reactants, right over here, and the products are unchanged. Catalyst doesn't do anything to change them. They just lower the activation energy. That's very important. Catalysts are very, very specific and will only work in a given direction. Always read the equation left to right unless otherwise specified. And they only work with certain reactions. One way a catalyst can speed up a reaction is by holding the reactants together and helping the bonds to break. So here we have ethylene, and here we have some hydrogen molecules. Both molecules are adsorbed. That means it gets stuck to the metal surface here. Okay? That's the blue surface. That's our catalyst. When you stick them together, they have a better chance to break bonds and join up with each other because they're right next to each other. So what's going on is this catalyst is providing a physical space for these two different reactants to come together and do their thing. Here's a situation you'll experience every day, whether you're a passenger in a car or driving, at a thing called catalytic converters. They're at in your exhaust system of your automobile. And all new automobiles, and frankly for the last couple of decades, are equipped with this. They're part of the exhaust systems. They're expensive, but they provide tremendous value to the environment. The exhaust gases coming from your car engine have carbon monoxide, nitrogen oxide, nitrogen dioxide. None of these are good for people or the environment, and unburned hydrocarbons. They will pass over these surfaces. You can kind of see the tube shape here, so the bad gases are coming through here. And then these are catalysts here. They're impregnated with catalysts. These catalysts promote the conversion of the bad gases that hurt us, turn it into carbon dioxide, water, and nitrogen. Much, much, much less harmful. Biological chemical reactions keep us all alive. And they have catalysts, but we don't call them catalysts in biology. They're called enzymes. And what you have here, here's your enzyme. And these are very physical shapes. This isn't magic. This is just small physical shapes on a very tiny, tiny scale. You've got a substrate, which is something that's going to come in and react and change into something else. The enzyme will grab it physically, and you call it the enzyme substrate complex. They then go through a reaction, and you can see how the enzyme here facilitates it. It brings it together, puts it in the right place, and then after they're done, they leave. Here's a pretty common experiment that you'll do, or demonstration you'll do either in chem or bio. Liver, okay? That has an enzyme called catalase. So if you take that out of the ground up liver there and throw it into hydrogen peroxide, it decomposes and you bubble out, you get oxygen gas and hydrogen gas and probably some water too.